All right, let's perform partial fraction decomposition with this rational function. Let's see what we can do. So the first thing you want to do is factor. Well, actually, you want to, I take that back. The first thing you want to do is check to see if the numerator has a polynomial with degree less than the degree of the polynomial in the denominator. So notice the numerator has degree 1 and the denominator has degree 2. So that is okay. That's what allows us to go ahead and perform a decomposition. So with that note, now we could actually factor the denominator. So let's try 2x and x. And we need factors of 12 that will help us make 5. Let's try a 4 here and a 3 here. We need to add 8x and then take away 3x, and that checks. That's in good shape. Now once you have it factored, notice you have two linear factors. 2x minus 3 is linear with multiplicity of 1, and x plus 4 is linear with multiplicity of 1. So what does that mean? Let's go off to the side here. And let's rewrite the rational function with its factors. If you have linear factors with multiplicity of 1, we simply break them apart with a constant a over the linear factor. And the second one will be a different constant. Let's call it b. It'll be over x plus 4. Now we do a little bit of algebra. Multiply the entire sides by the common denominator, and we get negative 11x is now equal to a times x plus 4 plus b times 2x minus 3. Let's call this equation triple star. With linear factors, it makes sense to try to test this equation. And what do we mean by that? We're going to test it by giving some x values. So let's test triple star with x equals 3 halves. So when x equals 3 halves, triple star becomes this equation, negative 33 over 2 is now equal to 3 halves plus 8 halves. Well, that's 11 halves. So we have 11 halves times a. The last term here, you get 0. You get 0 times b. So we're not going to write that. Well, what does this mean? This means that a is equal to negative 3. And we got one of our constants. Can we get b? Well, yeah. Why don't we try to test triple star again? This time, a little bit more obvious x value. Let's try to test it with x equals negative 4. If we get x equals negative 4, what becomes the triple star equation? It becomes negative 44 is equal to 0 times a, and now we have negative 11b. So what does that mean? That means b must be 4. So let's go back to our original work. Well, how do we decompose this big fraction into two little fractions? Let's go ahead and write it out. Negative 3 over 2x minus 3, and then plus 4 over the other denominator is x plus 4. And so this is an example of partial fraction decomposition with linear factors of multiplicity of 1.